Okay, everyone, I think that we're going to make a start now. So thanks very much, everyone, for joining this meetup. We're going to be talking on the topic Introduction to Azure Offensive Cloud Security. So in a few minutes, I'll share some slides and then we'll do some demos. So there's a lot of things that I would like to cover in this particular meetup, but I understand that we have very limited time. So hopefully, as time goes on, we'll be able to go through just share different experiences, different researches, and just different information with each other in this meetup group. So in case you do have any questions, please feel free to leave your questions in the question and answer box, and I'll get to that maybe at the middle or at the end of the whole presentation. I'll get to that. Another thing that I want to mention is if you go to the Meetup group, we actually just announced another event subsequent to this. So there'll be a follow-up event. And we're going to be having Carl Fossane. So Carl is going to be talking about adventures in Azure privilege escalation. If you've not yet registered for that, I would just encourage you to register for that event. I think it will be a very interesting one. Quick information about me. So my name is David Okeode. So I'm an independent cloud security consultant. And what I do is I help companies to secure their Azure and their AWS environments. And I do that through private expert level training and assessment. So the reason for sharing this information is just to sort of give you like a quick background of myself, of why I do, just some experience that I have. So I've also worked with different kinds of companies. So I've worked with small startups, I've worked with medium to large enterprises, I've worked with government organizations. So I've seen all kinds of Azure environments. So I've seen environments where they've just done a whole lift and shift from on-premises straight into Azure. Like they shut down the old data center and moved everything to Azure. I've also worked with companies that implement the application in a more modern way, where they don't have a single virtual machine that's running. So the entire environment is all platform services and serverless services. So I've seen different kinds of Azure environments just in my experience and in my career. So I have a blog that I maintain called azurehangout.com. So it's looking to be much more Azure securityhangout.com much more recently. Because again, I do some security blogging. So my latest two blogs on Azure infrastructure as code security and just using some free tools that's available from Microsoft that people may not know exist. So I also have a YouTube channel and a Twitter account. So let's get into the agenda actually. And actually, I forgot to mention, I'm also a Microsoft MVP. So the agenda for today, I'll just introduce briefly, the different approach to cloud security education. So for example, why did we even start this meetup group? And just to mention that if you have any interesting topic that has to do with Azure offensive security, we'll be happy to hear from you in this meetup group. So we have Carl that'll be speaking next week. We're working on another senior cloud security expert from Microsoft. So we're working with him already, so he's already committed that he's going to be having a session with us in October. So there's some very interesting Azure offensive security research that you're going to be learning in this meetup group. But yourself, if you have anything interesting that you want to share with the rest of the group, drop me a message, send me an email. I'm going to mainly focus on credential theft scenarios and look at some of those scenarios. However, hopefully you'll be able to get much more deeper in subsequent meetups and everything like that. So I'm also going to be introducing you to two tools today. So I'm going to be introducing you to an Azure attack framework tool called Lava and another tool created by the Azure Red team themselves called Stormtrooper. So in case you've not heard of these two tools, we just sort of do a brief introduction to them today. So one of the reasons why we're sort of like taking a different approach to this is that we already have a lot of presentations. We already have a lot of talks, a lot of videos that focus on best practice and the use of Azure security tools. So the Microsoft team just released a new blog collection called Azure Security Ninja, something like that. So the network team at Microsoft also just released another collection of blog called Azure Network Security Collection, something like that. And if you search on it on Google, you probably get to those links. So there's a lot of information, just tons of information. For example, if you look up the Azure Security Center Ninja document page, just tons of videos on how to use this tool and how to use that tool, how to use Azure Security Center, how to use Sentinel. And it's just a lot of how-to information already. And I think that's important. However, I think that there's a lot out there already. There's no need to try to reinvent the wheel. So it's also something that we know from years of experience on premises, that understanding attacker behavior and understanding how an attacker could exploit a system is an important part of cybersecurity education. And that's why we have just emphasis or disciplines around ethical hacking and pen testing, and we have courses and certifications around those different disciplines, because that's a very important part, right? And many organizations have adopted the whole concept of red team within their organization, where they actually have people that are employed to attack and to look to exploit the environment in the hope of making things better that way. So it's a very important part of cybersecurity education. Also, it helps us to know what not to do, right? So when we know that an attacker could easily exploit maybe something within our architecture, so then we learn to avoid that sort of implementation when we are architecting our solutions in Azure. So that's very important. So when it comes to the rules of engagement, when we talk about Azure, so it's important to pay attention to this warning. And rather than go through everything in full details here, if you go to that shortened URL there, you'll be able to see Microsoft listed rules of engagement for Azure attack scenarios. In other words, what are we allowed to do? What's the boundary that we should not or we must not cross? And there are serious consequences if we violate those boundaries. In essence, if you read that document in essence, what it's saying is this: whatever you do, do not do anything that can impact other Azure customers. So that's the whole, if you look at everything, it's all boiled down to that. It's like, okay, you got a virtual machine in Azure, you're hosting certain applications, that's fine for you to pen test that, right? So you're okay to do that. However, do not start trying to do like a distributed denial of service attack or a volumetric type attack. Because if you do that, that could impact on other customers that you're sharing the same network with, right? And that's not allowed. So anything that you could do, maybe you're targeting your own application. So for example, if I create an Azure storage account, right? And maybe I'm using something like just some DNS exploit tools to look for Azure storage accounts to exploit, I should not target other Azure customers. I should focus only on storage accounts that belongs to the accounts that the Azure accounts or the Azure subscriptions that are my own. So that way I'm not crossing over to affect other Azure customers. So that's like the main thing around that. If we violate that, that could lead to legal action being brought against us by Microsoft. It could even lead to Microsoft requiring us to pay damages. So again, this could be something that could be very costly. The Azure cloud is Microsoft computing platform. Sorry, Microsoft Cloud Computing Platform. And the Azure cloud is massively complex, right? That's why security can be tough sometimes. It's also massively growing, and it's very hard for many people to keep up with what's going on Azure, right? So we have more services that are being added all the time. We have new features that are being added all the time. Microsoft Ignite will be coming up in a few weeks' time. Microsoft are probably going to announce new services. They're going to announce new capabilities for existing services. So it's just something that's very hard to keep up with. However, this is sort of like just things that are really locked down when it comes to the Azure architecture. So I'll share about 3-4 slides with you around just the Azure architecture and the hierarchy, because that's important to know this as someone that's doing offensive security. It's important to know this. So for example, the Azure platform itself, it has 4 distinct clouds. So we have the Azure public cloud, we have the Azure US Government cloud, we have the 2 national sovereign clouds, which are Azure Germany and Azure China. So it also has, if you look at the regions that are available for the different clouds, so for example, Azure Public has about 40 regions at the moment. The US government has about 7 regions at the moment. So the 7 regions that the US government has, 3 of them are like just US government, 2 of them are US Department of Defense regions, and there are 2 secret regions that are not disclosed. So the locations are not disclosed, but they exist. So that's what makes that 7 regions that we have for Azure US government and DoD. So Azure Germany only has 2 regions, and the same with Azure China. So Azure China actually has 4 regions now. So they added 2 more regions. So what Microsoft have also done is they've announced 8 new regions that are coming. So they're currently building them. And that includes locations like Spain and Mexico and Italy and Qatar and Poland. So they're building more regions when it comes to the public side. Also on the Azure US government side, they're building 1 new secret region. So the location will not be disclosed, but they're building that in that region. Also, when you look at the different regions that exist, there's this concept of availability zone, which are distinct data centers within the region that's only available in only 10 regions. So it's a fairly new concept in Azure, the concept of availability zone. So it's not as if it's widespread yet, but the goal is to make that more widespread. Well, the importance of looking at or understanding the different clouds that exist is that depending on the cloud platform that we're dealing with, the API endpoints are different. So that's very important to know. So whether it's Azure Public, whether it's a US government, whether it's China or Germany, the API endpoints are different. The portal endpoints, the resource manager endpoints, even the individual service API endpoints are different for them. So for example, the resource manager endpoint for the public regions, so that's management.azure.com, and the Azure AD API endpoint of that is graph.windows.net. However, for the Azure China cloud, for the Azure China cloud, that's management.chinacloudapi.cn, and the Azure AD is graph.chinacloudapi.cn. So the one for Germany is also management.microsoftazure.de, and the Azure AD endpoint of that is graph.cloudapi.de. So it's just important to know this because, so for example, if one were to get like a credential that's or working with a customer or working with an organization that's using different clouds, the API endpoints that you target with any credential that's probably obtained, for example, may be different depending on which cloud environment or which cloud platform that you're dealing with. So it's important to note that. So here's the one for the Azure US Government. So the Azure US Government, the resource manager endpoint is management.usgovcloudapi.net, while the one for the Azure AD for that is actually the same as the public one, which is graph.windows.net. So when it comes to the concept of Azure Resource Hierarchy, because that's also important when we look in more details in future meetups on just different ways to move laterally within the Azure environment and to open backdoors and other type of information. So the Azure Resource Hierarchy, so we have Azure AD, which is what does the authentication. So in order to access anything within an Azure environment, you need to have a token issued by Azure AD. So then we can, many organizations are using this concept of management group. It's a newer concept that not every organization are using yet. But I believe according to Microsoft, like the top 300 Azure customers are already using management group, and a lot more are using management group. It's a way to group all the subscriptions that belongs to your organization, that belongs to Azure AD tenants under one root management group and have multiple child management groups under that. So we can have one root management group with child management groups under that. And the significance of this is to understand. So for example, if someone is able to exploit a credential that has access on this level, for example, on the root management group level, which means that access also moves across to all the subscriptions within your environment, right? So for example, if I'm doing like a check and you see something like user access administrator, which is the role that someone that's a global admin in Azure AD can enable a simple option and grant themselves permission to all the subscriptions within the environment by giving them some permission through the root management group, right? And that's a way to move laterally, for example. So someone is able to exploit like a credential and then being able to give access to all the subscriptions within the environment, which is just a simple option in Azure AD. So that's very powerful. But it's understanding this hierarchy that will help us to know what can be taken advantage of in some areas and what can't be in some areas. So then we have our subscriptions, which is sort of like the payment accounts for our Azure environment. So an organization can have more than one subscription linked to the same Azure AD tenant. And that's something that you see that's common for many organizations is they will have multiple subscriptions. And then we can have our resource groups, and then we can have our actual resources, which are the services that are probably hosting our data or hosting our applications under that. So that's the Azure Resource Hierarchy. It's important to know that from an offensive security perspective. So it's important to understand the Azure Resource Manager architecture. And actually, a few things that we're going to be looking at today when I get to the demo will be around this area of understanding the Azure Resource Manager architecture, because it's going to help us to know what are the different entry points that could be possible, can help us to understand the several ways that an attacker could exploit to get access to the management plane of our Azure environment. So that's the significance of this. So let's start by looking at what methods do we have to be able to interact with Azure, maybe to be able to deploy or manage resources in Azure? We have the Azure portal. We have command line tools like Azure PowerShell and Azure CLI. And we can use REST client also, just REST clients like call to command line on Linux or Windows, or use even something like Postman. So then it's important to also know, so for example, like the Azure PowerShell and the Azure CLI, those two command line tools does make use of Azure SDKs. That's how they interact with that. So, but it's important to also note that all these interfaces, whether it's PowerShell, Portal, CLI, or just REST client, all of these interfaces are communicating with a single API endpoint, which is called Azure Resource Manager, right? And the way to think about Azure Resource Manager is it's a centralized layer for resource management in Azure, right? Every management of resources that we do in Azure has to go through Azure Resource Manager. So that makes it something that's very critical when we're talking about things like offensive security, for example. Resource Manager uses Azure AD for authentication, and it uses role-based access control for authorization. Excuse me. It uses Azure AD for authentication and uses role-based access control for authorization. So what that means is that it doesn't matter what interface that we're using, regardless, right? Authentication and access works the same way. You have to authenticate to Azure AD to obtain an access token that has an expiry, and then you're granted access to the Azure environment based on what's configured for role-based access control. So that's how that's structured, and that's how that works. And Resource Manager has resource providers under it. So resource providers what manages the actual services in Azure, right? So every resource in Azure is managed by a resource provider. So for example, things like virtual machine is managed by the compute resource provider, the storage account is managed by the storage resource provider, and on and on. There are also a few services in Azure. So not very many at this point. There's actually just about 8 services in Azure that supports direct integration with Azure AD for authentication. So what that means is, so for example, if I'm hosting, if I have like an Azure Key Vault, for example, I could integrate Azure Key. I could have so Azure Key Vault is integrated with Azure AD. So what that means is that I could have the user account in Azure AD to give them permission to the data plane of the services. The security significance of that also means that, for example, if one of these accounts were to be compromised in Azure AD, depending on what data plane access that account has to different services in Azure, the user may be able to access more than the management plane, and actually to be able to access data that you're storing in some services that supports Azure AD authentication. So just about 8 services at the moment that support Azure AD authentication in Azure, and I think Microsoft are looking to improve on that. So let's look at a scenario. Let's look at some scenarios today, and then I'll get into the demo for today, and then we'll see where we are before we take questions. So let's look at this scenario. So in order, when we're talking about offensive security, in order for an attacker to exploit a victim's environment, and when we talk about exploiting a victim's environment, that could mean you're accessing internal or private data for that organization. That could mean maybe just accessing or using services without authorization, right? So things like crypto mining. In that case, you're not just looking to even access data or bring anything down. Again, remember that there's a boundary that we mustn't go outside what we own. So we mustn't impact on the customers. So, but looking at that in terms of maybe even just using services that you're not authorized to use and all those other stuff, so things like crypto mining, or even trying to open backdoors into the environment of a victim, or being able to persist access into an environment victim, it usually involves gaining some form of access to Resource Manager. So typically, usually, it's not in all cases, but usually one of the first places to start is gaining access to Resource Manager in one way or another. So how does an attacker gain access to Resource Manager, which is this centralized management plane for Azure? How does an attacker do that, right? So remember that access to Resource Manager is controlled or requires an Azure AD issued token. So you have to have an Azure AD issued token to be able to access Azure Resource Manager. And there are 3 main ways that we can use to obtain that token. So having an Azure AD user account. So gaining access to an Azure AD user account with a username and password, then you can use that to access Azure Resource Manager. Or gaining access to an Azure AD Service Principal, which is an application account, then you can use that to access Resource Manager. Or another option is to actually steal an issued access token. So this is where someone has actually used either the username and password to authenticate, and now they have a token from Azure AD, or where an application already used their service principal to authenticate to Azure AD, and now they have an access token, and then the access token can then be stolen and be used by an attacker to access Resource Manager, and potentially, as we discussed, even services that use Azure AD. However, what methods does an attacker have to gain access to one of these three in order to be able to access this? What are the methods that are available? So let's look at some of them. So for example, an attacker could target users and administrators, and they could use methods like phishing attacks to try to steal user account credentials. So maybe trying to install malware on their laptops, right? Using keyloggers and trying to steal their credentials that way. So that's one option. So an attacker could also target DevOps system. In this case, it's going to be maybe less user accounts, but more about service principals. So people could be putting service principal information, like the client ID and the secret key, putting that in source control, or they could be putting them as environment variables on CI/CD tools like Azure Pipelines or Jenkins, as we mentioned. So things like that an attacker could use to exploit or use that option. Another option that an attacker could do is to target the admin workstation. And I'll show you a demo of this one in particular. So where an attacker could target an admin workstation, and the goal here is usually number 3, not to really steal user account, credential, or to steal service principal, but it's still the Azure AD issued access token. And here's the danger of this one. This is why this one is a bit more dangerous. Because for the first one, you could probably just implement defenses like MFA, right? So even if the attacker is able to phish the user or maybe install malware on their PC, and they have key login to obtain the username and password, the user still has another factor of authentication. However, if you're stealing the issued access token, the user already completed both the authentication and the MFA approval. So they've already gone through that process and they already have a token. Now you're now stealing the token that they already have, which means that MFA doesn't impact this in any way. So we'll see what that looks like. So that's one way. So attack the environment just to steal the cache token from the users, from the admin's workstation. Another one is to attack Azure hosted applications. So in this case, so if you've not yet seen my video on YouTube, how vulnerable is your Azure environment? So go see that. I'll show you the slides to that in a few minutes, but I won't do the demo again. But if you want to go see a sample demo of that, go look at that. So this is where an attacker is targeting, especially services that support configuration settings or services that support managed identities in Azure. Right? There are only just few services that support both. So for example, there are about 23 services currently in Azure that support managed identity. So managed identity is a way where you use managed service principals to give permission to your code to different aspects of your Azure environment, right? So you create an identity for the resource that the code is running on, and then your application using the SDKs or just using a local API call to a local metadata service can obtain the access token from Azure AD in a transparent way. However, an attacker could also, if they could exploit your code, if there's vulnerabilities in your code, which is what I showed in the demo that I'm referring to. If there's a vulnerability in your code that an attacker could exploit, then they could use that depending on what type of vulnerability that is. Let's say it's something like a remote code execution. They could use that to obtain a token using managed identity, and then use that to move laterally within your environment. But these are just different options that an attacker could use to get their hands on a credential that gives them access to Resource Manager. This is by no means an exhaustive list. This is just saying these are some of the ways that I've seen in the past, and some of them that I've demoed and I've tested in the past, or even some of them in my own research that I've seen in the past. So, but these are different options where that could be used. Okay, so what I'll do is I'll actually go to show you like an example of the credential type from admin workstation, show you a sample of that very quickly without taking too much time because I'm conscious of the time here. But essentially what I'm going to be showing in this demo is this. So a normal admin, right, is going to authenticate to Azure AD to obtain a token that they can then use to access their Azure subscription where they have their resources. However, whenever they do that, right, if they're using something like Azure Partial or Azure CLI, that credential is cached on the user's machine. So one attacker could then do is so rather than trying to steal credentials, which again MFA will limit that, and all the other stuff, or whether trying to attack DevOps system, is being able to attack this workstation and then stealing credential, in this case, being able to obtain that cached credential, and with nothing else but just that cached credential, an attacker could then make calls to Azure Resource Manager and then begin to explore around the environment. So let me go over to show you let's go to, so I've got two main machines here. So here's a Windows machine over here. So we'll call this the victims environment. So you can see it has some PowerShell scripts and stuff on the desktop. And I have another environment which will say this is sort of like the attacker environment. You can see it doesn't have any of that stuff on the desktop. So let's go back to the victims environment. So the first thing is the victim authenticates to Azure. So Azure PowerShell is installed, victim is an admin, just doing the normal stuff. So victim goes connect AZ account, and victim wants to connect to the Azure environment to some management tasks. So let's go get the victim's information. Let's grab that. And if I go to next, put in the victim's credential. And just to show you the MFA thing that I'm talking about. So this user, for example, has MFA, or the MFA is configured for this user, which I actually have my phone in here. So I'll go ahead and approve that MFA request, and I've just approved that, and that's gone through now. So this user now has access to the environment. They can do get AZ resource group and see like everything that's happened, and just being able to just use based on whatever they have in robust access control, they can begin to use that. However, what happened here is the credential that was obtained, the token that was obtained from Azure AD when the user authenticated and did MFA, is cached locally on this system. And just a few information about that token. So for example, if I do, let's get the item, let's filter for anything that's .az. And so that's the location where that credential, that cached credential is stored. So it's stored in that folder right there. And actually, if I go to if I go to under that Azure admin, you see the different files that are stored locally. But where the actual access token that Azure AD issued is stored inside that token cache.dat. So that's where that is stored. So actually, if I go to right click on that, if I open that with Visual Studio Code, is going to throw up a warning to say, this is a binary file. Are you sure you want to open it? I'll just go ahead and say, open it anyway. So I opened that anyway. Let's use word wrap so we can see what that looks like. So however, so what you're seeing here is you're seeing the, so that's, and you can actually see different tokens, right, that are cached on this system. You can see the refresh token, you can see the access token, and you can see other things like the extended, you can see the ID token and other information there. So however, if I go to, so for example, this access token, you can see the expiry of this access token is that, so it's an epoch time format. However, if you have a look at that, it's essentially the default is 1 hour. So that token expires after 1 hour, in which case the application can try to do a background refresh of the token to refresh that token. So, but that's 1 hour by default. So what an attacker could do is, for example, I have a PowerShell script here, and that could maybe not be a PowerShell script. That could be in form of a malware that just harvests that folder from your system. Actually, before I do that, let me show you the permissions here to show you who has permissions to that folder, because that's also important to know. So if I do get ACL, and I specify the path to that. So I want to get ACL for .azure. And what I'll do is actually, if I could get not only for .azure, I want to get for that exactly the cache credential there. So if I do that, and let's wrap it a bit. So if I do, so you can see that the tree has full control. So system has full control. That's a separate conversation by itself. So system has full control. Any built-in administrator has full control to be able to essentially gain access to that token over there. And the owner itself, which is the actual owner of that token, also has full control. So, but administrators and system has full control, and that could be exploited. So we're not going into that today. Again, maybe that's for another, meetup at some other point. There is actually so Matt Levy. So shout out to Matt for opening my eyes to this. So in Azure, there is this. Let me go to my Azure environment. Let's see if I can drag these away. So let's remove that. Don't want to pin it. Okay. Let's see if I can go to my Azure environment. And there's actually there's a feature for Azure Virtual Machine called the run command. So which could be exploited because it can also use the system permission, and that could be exploited in a user's environment. So for example, run things like PowerShell script, if I don't have access to a virtual machine, but you have necessary permissions in Azure using run commands to run certain scripts that can exfiltrate credential and exfiltrate that to a command and control center somewhere. So that's something so you can do something like run PowerShell script and other stuff, but that's for another day. But shout out to Matt for really pointing that out to me on one of our calls that we had recently. So let me go back to the environment here. So essentially, so this script is actually my GitHub page. So if you go to GitHub/David you'll see like this script posted there. I think it's under Azure Offensive, something like that repository. So what I'll do is I go ahead and run this. What it's going to do is it's just going to, let me bring up what I'm trying to do to help you to see. It's just going to export. It's going to go through like all the profiles on the system, and it's going to export any cached Azure credential, and it's going to push them to a storage account that maybe an attacker has set up. And then, so let's go to xview 1509. Let's make that a bit bigger. Oh, wow. I really need to move very fast. I don't think I'll be able to finish everything that I wanted to say. But anyways, let me finish this particular demo at least. So if I go under containers, and I go under the container called profiles. So it's currently empty, but we're just going to use the PowerShell script, which an attacker could have crafted to move everything. So let's run all of that. Oh, and it's failing. Oh, okay, so I think it's complaining about. Okay, let's just do some modification. Let's run that again. Okay, yep, that's done. So that's exploited that's exported that. So if I go to the storage account, if I refresh that, it's exported all the cache credentials. What it's going to do is going to run through. So if there's more than one user, it's just going to go through, look for that folder called .azure, zip everything in there, and push it out to a storage account. And now an attacker could then, once they've obtained this. So for example, I can go to generate a SAS token for that credential. So if I go to generate SAS token and URL, obtain the SAS URL there. If I go to the attacker system over here, and if I bring up Azure PowerShell, if I do things like get AZ resource group, it's going to say you're not logged into Azure. What are you doing? So it's going to say, no, you can't do anything. You need to log into Azure and run connect AZ account. But what an attacker could do, for example, is if I could go to download that's one that I just exported now. So let's go to download that. Actually, you know what? I think I'll just go. Yeah, so I've downloaded that. So what I'll do is if I go to open that, and what I'll do is I'll copy the entire folder. Copy that folder, go to that other folder locally, which again, you can see the other records because I don't have any access and all that stuff. So what I'll do is I'll just go ahead and just replace that. So if I go ahead and paste that, so replace the files in the destination. So it's replaced all the files in the destination. So what I'll do is I'll just go ahead and close PowerShell and reopen PowerShell. And now if I do get AZ resource group, now you can see that essentially having stolen that cached credential, essentially I don't need to authenticate. Essentially there's, it's bypass whatever MFA that's set up, and I'm now accessing Azure Resource Manager as this user that credential was just stolen. And this is not, I'm looking at the time here, so unfortunately I won't be able to show you all the other things I wanted to show. However, so, because the same thing exists for Linux also, right? So for example, if I go to a Linux system, if I go is login, and if I copy that, let's copy that. Let's open up a new browser, Firefox. Come on. So I really need to move on. So unfortunately, I think I underestimated the time that it's going to take to do all the stuff. Well, we'll see where we're at. Let's see where we're at with this. So if I go ahead and type in the code that we obtained earlier, and if I put the code in there and I click next to that, so it wants me to authenticate. So let's get the credential of the victim in this case. Go to next, and I put in the password. And do MFA. So MFA is prompting me, so I approve that. And having logged into that on Linux, for example, come on. Yep, so you said I've signed in now. So if I go back to this, so now I'm signed into this environment. So however, if I do a list dot Azure, so you can see the access token cached locally here. Again, an attacker could exploit that. So by exporting the access token and the Azure profile, they could export that within the environment and move that to another system and then essentially gain access to Azure Resource Manager that way. Okay, so let's go to round up now because I'm conscious that I've gone over the time. So what I'll do is we'll probably do like a second part to this later. So maybe that'll be after Mat 1. But once an attacker has a credential that way, some of the tools that an attacker could use to exploit the environment will be a tool like Lava. So I've talked about Lava a lot. It's just one of the favorite of mine. I absolutely love it. So Lava is a Microsoft Azure exploitation framework. It's inspired by another project called Pacu, which is for AWS. So if you're not familiar with Pacu, if you're familiar with Metasploit, essentially a similar thought pattern, which is an Azure exploitation framework that has modules that we could use to exploit an Azure environment. So it contains multiple exploitation modules for pen testing Azure environment. So it has all these modules. It has modules for exploiting Azure AD, VMs, VMSS, storage accounts, database, to perform privilege escalation, data exfiltration, and other type of methods. So the person that created Lava is Matt Levy, and that's Matt's Twitter account. So to download Lava, you can go to that GitHub URL, which is Matt Levy's GitHub account, and go to the Lava repository, and you'll be able to access that from there. So I will just go ahead and install Lava. However, so let's go to remove this F. I'll just show you like using Lava -R. I'll just show you using Lava, and then I'll stop there for today because of the time. So first thing that we'll do is let's go ahead and download Lava. We're gonna clone the repository from GitHub. So git clone, and then I'm gonna clone that from Matt's account. So that's cloned that. So if I go to cd Lava, and if I do a list, you see that it's written in Python. So if I go ahead and execute that, if I do Python 3 lava.py, and so now I'm within the framework itself. So now within this framework, so for example, if I do like a list that will show me all the different modules that exist that we can use for exploitation within this environment. So you can see the Active Directory modules and other stuff. So for example, one of the things after you obtain a credential is to be able to see what access does that credential have, right? To be able to see that, for example, you could use the privilege escalation module. You can use the privilege show to see, what exactly does that even have. You can even start by doing something like who am I and do that. So for example, if I want to execute any of these modules, I can do exec and I can put in the name of the module that I want to execute. In this case, privilege show. And if I run that, so it's going to run through the access that each user has, and it's pointing out to me that this user has contributor permission within this Azure environment, and it's showing me that the user essentially has permission to do almost everything with some limitations. So essentially, then we can begin to now go, okay, suggest to me ways to exploit storage account. So for example, we can do execute storage account get keys, for example. So exec, because that permission has permission to storage account. So if I do stg get keys, so let's do stg storage get keys, and that's going to go through and dump all the keys for accessing storage account in that environment. So, and then you can see just different option exploitation modules that we could use. So I've talked for too long, and I think that there's a lot more things that we could be looking at, but I think that we'll probably have to stop there so we do not go ahead of time. So let me see. I can see that there's a question in the chat window. So Samuel asked the question, what Microsoft course can we check for this demo content? So there is no Microsoft course that covers things like Azure Offensive Security at the moment. So there's none really that focuses on that. So that's why we have the Meetup group, is to just place some focus around this. So what I could do is, so the URL that I mentioned, which is the GitHub URL for Matt, the Lava framework, I'll go ahead and post that in the chat window. So let's go to reply and put that in there. So unfortunately, there's none, Samuel, that I can really recommend. So that's why we're having this meetup, is because there's not been that much focus on offensive security for the cloud. Okay, so if there are no other questions, I think that's where we'll probably just stop here for today. So there's still content around just again introducing you more details to Lava and to Stormtrooper that I've not been able to go through, but we'll find time to go through that in further meetups. However, for now, I would strongly encourage you, if you've not yet registered for our next meetup, which will be September 29th, please go ahead and register for that. We have Carl Fossine, who is the practice director at Net SPI. So Carl is one of the forefront people when it comes to offensive research for Azure. And Carl actually wrote another tool called Microburst, which is another tool for, it's sort of like an Azure exploitation framework written in PowerShell, but Carl wrote that. So I encourage you to go register for the event, and we'll see you next time. So have a wonderful day, afternoon, evening, everyone. So bye for now.